Hey everyone, welcome back to another episode of Tech Talks with Santosh. And today we have a very special guest, Prateek Bhatnagar, with us. So Prateek was previously working as in Google with Period team. So over to you, Prateek. I mean, you can just introduce yourself.
Sure, yes. So, hey everyone, I'm Prateek Bhatnagar. I'm currently working in Uber on the developer platform and a few other DevOps tooling. So, and I guess as we know that we are talking about Core Web Vitals today, funny enough, this is more related to my previous job than my current job. But yeah, it's an interesting topic and basically has caught a lot of public interest due to a few reasons that we will soon discuss. But one thing there, so like my previous team with Google was not actually Preact. Google does not officially contribute to Preact. I happen to be a Google employee and a Preact contributor. And also, same thing is with Jason, who happened to be a Chrome engineer and a Preact, but there's no like official uh, supporters like or official employees doing work on Preact.
Oh,
React is just an open source framework that we contribute on our time. What I used to do with Google was I basically have been in multiple teams at Google, but my last team was Google Chrome. And there, basically, we work with Next.js and a few other frameworks. Like when in some of the last days when I was about to leave, we started looking at with other frameworks as well. I guess a few of them was like Nuxt.js for Vue and stuff. But our core focus was basically building the right tooling for these or building the right guardrails in these frameworks. And one of the core focuses was how do we keep same core web vitals to score when somebody is opting in for with Next.js, when somebody is opting in with Nuxt, or at least publish principles or guidelines for other frameworks as well. Like so, if you do X, Y, and Z, then you have good guardrails for your users that they don't have a poor core web vitals to score.
oh,
Yeah, so that's more of an introduction. I know it's a bit lengthy.
it's not. I mean, I just saw some tweet today or yesterday regarding Next.js, some Next.js release. Not
Mhm.
Next.js, but I think Next.js, right?
The
So
next
I
yes,
think,
yes,
yeah. So, cool.
yeah. So
So,
that had like one of my very significant contributions, which was the
mhm.
automatic font optimizations. And interesting enough, that optimization itself is basically improves your core web vitals score as well. So that was focused heavily on FCP, and basically it removes one extra round trip to third-party font providers, directly improves your FCP, and as a side effect also improves your LCP. There's very little correlation, but in practice we have seen like if you unblock your loading pipeline for other assets, then the actual element which would affect LCP would load earlier. I feel that we are going a little bit into too much this detail of Core Web
Yeah,
Vitals without actually going on what Core Web Vitals is.
exactly.
What do you think?
So,
Right.
yeah, sure. So let's start with what is core web vitals first. Then in that case,
Right. Yeah. Exactly. That would be a that would be a good start to this. So, Core Web Vitals is a set of performance metrics which are very heavily used on users' perspective. Currently, there are three Core Web Vitals. Excuse me. There are three core web vitals. First is LCP, which is largest contentful paint. It basically is heavily focused on the loading side of it, like how soon does the largest contentful paint happens. We'll go and I'll try to explain what exactly these three are, but I'll briefly first go over which are the three core web vitals. First one was LCP. Second one is FID or the first input delay. This is basically the first time a user is trying to do something on your web app. How much is there a lag between you responding to their action. For example, I'm trying to type in a text box, but I have typed like 4 keystrokes, nothing has appeared. Then suddenly all of them appear. So that's the lag between input and actually responding to it. That is your first input delay. And the third one is CLS. This is around visual stability. So basically, imagine. I swear I have a lot of good examples, but none of them are coming to me right now. For example, like imagine you're trying to go and click on a button, but suddenly a content loads on the top, and that button itself shifts down, and then you press something which was not your intention. The whole content shifts down. This is a very common problem in web with
Yep.
images, with ads, and everything. If developers are not careful, if they just leave an image tag without any sizing or without proper precautions, or ads, imagine you're trying to buy something and that buy button actually, because content is loaded on the top of the page, that buy button actually shifts down and you press subscribe,
Yep.
right? Or you subscribe to something which you did not intend it. This is a very common problem seen on a lot of web applications. This is basically CLS is what this thing measures. So if there is content shifting, CLS basically is how much the actual body shifted from its original position, and then that's basically that gives you a score. If CLS is 1, that's basically your content shifted by 100 viewport height, like the entire page shifted by its entirety of height. Its value basically ranges from 0 to 1, 0 being everything was stable and there where it was, 1 being it shifted 100% of the body height, right? FID, on the other hand, is in milliseconds. What was the lag between user input and response to it? And CLS is again in, LCP is again in milliseconds on how long did it take from the first byte to LCP to happen.
That's
Yeah,
great.
these are the 3 core web vitals.
So,
These are, sorry,
go ahead.
yeah, go ahead.
Yeah, so we were about to actually, I was about to ask next question, which is why it is important to know about core web vitals, because I can see a lot of devs are actually still not aware of it. But I mean, Chrome is actually making some changes to include web vitals as part of your
Dev
application, right?
tooling.
I mean, yeah.
Yeah, there are 2 very big reasons. First is this set of performance metrics are very user driven. They are not driven based on engineering practices. They are not driven based on how fast some there's no subjectivity to it that we feel this will depict how fast your website will load. These are basically how fast users will perceive your web application to be. Right, that is a very important thing, that these are very user-facing metrics. Actually, as a matter of fact, like if you see FID is something that you cannot even measure in a lab setting. That's a purely real user metric. You can only get this when the web application is being used by the users. You can get an idea of it, and you can get a good like the exact number from a real user metrics, but there is no sure shot way of getting a definitive number by synthetic lab testing for FID. So that's like one of the main reasons that these are very user centric. Second, I feel this is this is why a lot of businesses are driven, but not engineering. The second biggest reason is basically Google will now take Web Vitals as an indicator or as one of the pillars while giving you search ranking, right? So if your core Web Vitals are great, your search ranking is basically good as well. If they go down, your they will affect your search ranking as well, right? So those are the 2 things. For if there's a motivation from engineering side, take it like that. That these tell you how users will perceive your product. If you need a motivation for your business side, take it that your search rankings will be affected,
Yeah.
right?
So let's move on to our next question. So we discussed about LCP, FID, and CLS. We know what those are, but the important thing to actually measure those, right? So how we can actually measure the core web vitals? What are the
Mhm.
tools, or what are the tools which are available? So.
Right. In order to measure web vitals, like there are multiple things. So, for example, you can always do web page test with a very low
Mm-hmm.
level device that will give you a good idea. So, uh, since as I said, like these are very user facing, so you need to know your audience segment.
Mm-hmm.
The way core web vitals are basically measured is basically what is your core web vital score, like each vital score on your P75, right? This is not like how does it perform on Moto G4. This is not how does it perform on iPhones. This is
Mm-hmm.
basically given a corpus of your traffic. Where does these score lie on your P75? Right? So your LCP, sorry, your CLS needs to be between 250 to 500 ms. Actually, would you mind if I just give you the exact numbers? I definitely need to look these up.
Yeah, sure, sure.
Uh, uh,
If you want to share the
threshold.
screen, you can do that.
I am not sure, but I will definitely give you the link,
Hmm.
which can. How do I post this for
Yeah,
like
let
public
me do that.
comments? Yeah, this is the source of truth,
Mm-hmm.
which everyone can take a look at. So sorry, not 250. This is 2.5. If your LCP is below 2.5, you're good. If your LCP is above 4 seconds, then that's basically considered as a poor LCP, right? And that's these all values are need to be calculated on your 75th percentile. For
Mm-hmm.
FID, a good range is below 100 ms versus
Mm-hmm.
a poor range is above 300 ms, right? So your website definitely needs to respond to every user action within 100 ms
Oh, okay.
or your first input within 100 ms. And CLS, as we discussed, like it needs to be below zero point 0.1, right? And I guess a poor threshold is 0.25. If
Mm-hmm.
it's more than 0.25, then probably what it tells you is your page is moving a lot, and
Mm-hmm.
it's pretty obvious that the user will be pretty frustrated with that kind of reading experience or an e-commerce experience or whatever they're trying to do with your web application,
That's great.
right? Yeah. So coming back to tools,
Mm-hmm.
what we can do is go to web page test, know
Mm-hmm.
what your 75th percentile looks like, right? So for applications that I have profiled personally,
Mm-hmm.
I usually take their traffic corpus and try to see where basically their P75 lie. What kind of devices are their P75 users using? Is it a mobile device? Is it a desktop device? Is it a really slow connection? Is it a 3G connection? Is it a 4G connection? Basically, put those value in web page test and then run your lab result or your
Mm-hmm.
web page test, right? So this would bring you very close on where the CLS is, how much was, sorry, where the LCP is, how much was the CLS. FID is something that you still cannot measure here. So for
Oh.
FID, I'll come back to that. So these two also, I guess, when I was working with the Chrome team, we worked with the web platform, sorry, the web page test
Mm-hmm.
contributors, and now there's a clear cut denotion of where exactly LCP happened. So you don't need to look for it. Web page test, the thumbnail will basically tell you where exactly LCP occurred and how much was CLS when that loading experience was basically until that loading was happening on web page test,
Oh,
right?
I
So
get
these
it.
are the
Yeah.
two things. These are the two things that you can do for LCP and CLS. For
Mm-hmm.
FID or even for even getting all these numbers from real user metrics, there is uh, Web Vitals library from the Chrome team itself. I guess Philip wrote this library, and what you can do is you can add this library. It's pretty straightforward. Just add this library to your entry point and let this load before your application code runs, right?
Okay.
So the Performance Observer API, which is pretty much available in all this library relies on Performance Observer API, which
Mm-hmm.
is in a lot of browsers, I guess. So it uses Performance Observer API to calculate these three scores and gives back to you. Then basically it's up to you where to ingest data, and you might have to do a little bit of analytics. And hey,
Mm-hmm.
I need to calculate my P75. There is a crude way of doing this. Like let's just send this to Google Analytics, all these values, but Google Analytics tends to give you an average of everything. Like it will give you an average of LCP number for a day or for an hour. If you really need to get literally every request, that might need a little bit of work. But more and more frameworks are actually coming with innovative way on how you can actually get and ingest these three values in your applications, and then easily identify these three values for your users, like for your actual users, so that you have
Mm-hmm.
the definitive number and you're not trying to guess it in a lab setting, right? So that's basically two of the major ways that I have been doing this, or I did this when I was with Chrome. I'm sure the Chrome team and people like shout out to Shubi, Raz, Alex, and Gerald, and a few others. These were the people who were doing it even when I left, and I'm sure like and Hussein. So yeah, I'm sure they might have improved on how we used to do that, but these are good ways of how to get an idea of where your core web items store lie.
So I just want to understand, where does Lighthouse fit in?
The Lighthouse has. I'm a little bit away from this. I'm not sure if Lighthouse gives you these score as of now or not. But what it can do is basically Lighthouse, you have throttle conditions, right? And it can try to find out how much did the page shift and what was the LCP. However, the problem is the throttling might not represent your P75 in this, right? I am not 100% sure if Lighthouse right now gives these values or not. Lighthouse team might be the best people to answer this. But even if they do, like matching your P75 with these are all lab tested tools, right? So matching that environment, matching that network latency, matching that device speed are the more critical things when you are trying to measure core web vitals. When you try to do this on a good phone with a good network, they will give you a very different value. So this is where it's a little bit different from other perf metrics. For example, take bundle size. It doesn't matter if you load it on an iPhone, if you or on Moto G4, that number will basically stay the same, right? How much code you are loading, or basically what was the page load time on a given network, on a given device. That would remain same if you throttle the condition. But here, basically, you'll need to know your P70 first of all to actually get a good idea. But the I again repeat, like the most definitive way is to actually get the real user metrics and then find the P70 stuff. Yeah.
So as you mentioned, you have all. I mean, you went through some research while doing these changes, right? So, what you think are the common causes for these issues?
Right, that's a good question. Uh, a lot of my research and looking into core web vitals was highly focused around LCP because that was the most definitive one, and basically that's where I started looking into it. Few of the most common problems were images. We send like still as web has progressed, where frameworks has matured, web applications just tend to send overly sized, hugely over sized images to their web applications. What basically, so we need to understand how LCP is calculated. It basically takes in the first viewport of the user, then takes in the biggest image which is there, or if it's not, like then the image inside an SVG tag, or the biggest block element. If these are not found, then so like these three or four things. There are, I guess, set of four. I'm missing one. Um, so it picks whichever loads first out of these four, and that becomes your largest contentful paint. If there's a hero image, then basically that becomes that most of the time that becomes your LCP. If there is a large bit of chunk of text, like in really big bold letters, in a block element, then that would become your LCP if there's no image above it, right? So for product listing pages, it's the listing images of products that become the LCP. And in case of hero images, that was like one of the biggest and most common thing that we really found hugely oversized images. And also in terms of responsive websites, we do responsive design in terms to fit the content in a smaller screen, but we
Right.
don't swap the assets. We still load the same assets, or we never dynamically size according to the size of the screen. So that's like another thing that contributes a lot to your LCP. However, there's a very common thing that there can be requests blocking your LCP request. Imagine if there's an image, you've sized it well, and everything else is fine. But now there are requests before that image request which are blocking or basically choking your network. So those are also a very common problem. For example, fonts are loaded with the highest fonts and CSS are loaded with some of the highest priorities when assets are being downloaded in the browser, right? So if there's a third-party font request, then that basically blocks your image request. Image request can, based on where it is on viewport, how much is in size, can either be medium or high, right? So you need to take care that your LCP element is not being blocked or choked into the network by anything else, which is at a higher priority. Funny enough, premature optimization was also a very common thing. When we talk about images, we have read at a lot of places that we should do lazy loading of images, right? Now, for lazy loading of images, a lot of people do what they do is go onto npm, search for a JavaScript library, and do that library. And then when they test on their devices, it basically works until you don't until you don't scroll an image into a viewport, it does not load. It basically sounds fine, but here's the problem. Now your images are JavaScript bound. Even if you do server-side rendering, basically this library, what it will do is it will never render even the images in the first viewport. So what happens is the flow is your markup gets downloaded, your CSS gets downloaded, and your then with third number is that's when your JavaScript comes. This is the usual flow of how browser downloads based on priorities. If you don't touch anything, so this is the default flow of it. So third number is when your JavaScript starts coming in. Now your JavaScript has to be downloaded. React needs to hydrate it, right? And we are already at fourth or fifth step. And then sixth step is this library gets bootstrapped. When this viewport image lazy loading library gets bootstrapped, then it suddenly realizes, oh no, this image was supposed to be on. This is literally in the viewport right now, and this should be downloaded right away. So after sixth step, your JavaScript told the browser that you need to load this image. If this image tag wouldn't have been lazy loaded, the browser's pre-parser must have would have looked at this image tag and would have fired the request much early on. But there's literally like 6 steps after which browser now knows that it has to load the image. This is a very common problem which causes high number of LCP that without looking into it, a lot of developers just do image, lazy loading. Whereas, so browsers have, like, I won't say it's literally perfect, but browsers now have a lazy loading primitive for images. If See if you can work with that. If not, really make sure that your LCP elements are not bound by some kind of lazy loading mechanisms, which does not even let it fire the request until a lot of steps are already taken, or some JavaScript libraries bootstrap. So those are a few things where LCP is stuck. A few things for FID, like FID right now, the way that we build applications is one of the biggest culprits of a high LCP is how we do hydration, right? We do SSR, we give our SSR to the browser, and the browser paints it, all good and fine. But the problem is now it has to download few chunks of JavaScript. Now your chunks and the main chunk, like there are vendor chunk, there are chunks for the page, and then there's main chunk. They can get downloaded in any sequence. Now imagine if your vendor chunk, your pages chunk are downloaded first, and then the main chunk comes. Basically, you have to wait for all these chunks to be ready in the browser before React can hydrate. That's how React hydrates it. Does not Partial hydration is not very common in practice today, right?
Right.
So all of these then start executing, and they all execute together in a big chunk of JavaScript execution. Also, there's a Webpack Bootstrap chunk related to it, like Webpack itself bootstraps, and then download the download different JavaScript files and then bootstrap them. This is a huge chunk of JavaScript activities. If you do React profile of a common React application, you'll see there's a big chunk of JavaScript activity in the beginning of the timeline. That's like one of a very common culprit. If imagine if your user is trying to do something, those 300 to 1 second, it's not very uncommon to see a 1 second of JavaScript activity that is unresponsive on main thread, right? So that's one of the biggest culprit, like a very easy, but still I'm not sure how mature it is or how easy to adopt it is right now. But concurrent mode is a very good answer to this, where React yields every 16 seconds to the main thread that, hey, just see if there is any pending input work, then let it first happen, then I can again. It basically divides that big chunk of JavaScript activity into windows of 16 ms of JavaScript activities. So if I try to do something, there will be a window after 16 ms where the browser can respond or where your application can respond to my inputs. Right. That's like one of the bigger answers to this problem lies. And then comes CLS. CLS is a very tricky one, though. There are too many things that affect CLS, and a lot of them are often found to be third party. You load ads, and you have no control on how big of an ad that would be on a particular screen. AMP deals this very beautifully, where they have AMP has a very, if you look at AMP pages, they have a very good way of maintaining stability. They know it upfront. They have an extension for ad in a way that they guarantee you that the ad loading of an ad will not shift your content. So you should definitely take a look at that. Fonts were another thing. Like when you choose fonts and their fallback font, if there is a considerable amount of difference in their height, it causes CLS.
Oh.
Imagine you are loading a font which is a lot more vertical in sense. So, and you first render your text with a fallback font, the font loads, and then suddenly tries to swap that font, and it has significant difference in height. Basically, it will have a cumulative or a compound effect on the stuff which is at the bottom of the page. The font will load, the content will jump, and you'll have a CLS. Also, again, like images. If your images are not pre-sized, they can load into a particular screen and then adjust themselves accordingly. Imagine you just tell an image that you need to acquire 100% width and leave the height up to it. Like that 100% width can mean different heights on different screens,
Exactly.
right? And thus the text is bound to shift whenever that image loads. So that is a very common culprit when it comes to CLS. Yeah. So those are the few things which I found were very common. Yeah.
That's why actually a lot of developers are actually pretty excited about having this font inlining and CSS critical CSS inlining, I think.
CSS critical inlining and font inlining basically saves you on first paint a
Yeah.
lot, and these are literally massive savings. So when they get out of your way, like an extra round trip to a third-party server, it gets out of your way. Now your bandwidth is basically open for your assets to be loaded, right? For your LCP element to be loaded, for your ads to be loaded, and for your JavaScript to be loaded. So now your FID and LCP, it's basically a cascading effect that it uh, affects the core web vitals, which are
Yeah.
actually there right now. FCP in itself is not a core web vital as of now, but it basically has a cascading effect on others. Yeah.
Okay, so let's move on to our last question. So now we discuss about the factors. Now we discuss about what are the common causes. How to improve this course now. So
Right. So improvement of score is basically, as I said, like identify your P75, look at your traffic, where is it coming from, and what segment do you really need to improve. Do you need to improve it on phones? Do you need to improve it on desktops? Do you need to improve it on really slow networks? Or do you need to improve it, or you can, have a leeway of a good network audience but slower devices. Identify where does your P75 live. Improving your P99 and P75 basically improves, like, is a guarantee that will improve your core web vitals. But yes, know your audience, know your users is one thing, and then start looking at how things are loading on your page. This has effect on at least FID and LCP. Is is your LCP element blocked on something else? Is your LCP element being requested by your JavaScript, or did your LCP element at least started loading right away when the markup came down? Right? It should not be blocked by anything else. It should not be blocked behind JavaScript or fonts or any other such thing. Your FID should not be like that first segment, that first big chunk of JavaScript activity should not be really, really huge. If it is huge, then do lazy loading of your. Basically, you need to split your first initial set of JavaScript being downloaded. That's like one of the few things. And CLS is more observable. That if your page is really shifting, then you need to check. Most of the tools that are there in the wild right now give you the element which is causing the shift. So that's a bit easier to locate, but it's harder to tackle that because it might be a third-party tool after all. So that's where basically you might want to work a little bit with either the owner of that third party tool, or take a look on, basically, if it's your first party code, then great, you can probably just go and fix it yourself. One thing I'd like to mention, for at least this is what I know, I'm sure there must be other great solutions to this as well, but Next.js has this dashboard for every website. It's not Next.js, basically Vercel. So for every web application uh, that is hosted on Vercel, you are being built with Next.js, and I feel a few other frameworks are also supported. They give you a real experiences score, which basically comprises of these 3 or 4 things. So you can at least get an idea of LCP, CLS, and like this FID right away. If you just go to their analytics dashboard of your project, they will show you right away. Let me find if I have one. Okay. Yeah, yeah, it's loading. Okay. Yeah. This is pretty. Okay. Something is happening that the data did not load. Okay. The demo gods are not so kind on me today.
Happens.
But yeah. Yeah. Yeah, but they definitely have this analytics
Mm-hmm.
dashboard already integrated
Oh, that's good.
for their websites. Yeah. Yeah, so that's basically all. And also, if you do not want to host on Vercel, then
Mm-hmm.
Next.js has this report. I should they have this API which I should remember because I literally proposed that API and implemented it. Next.js for right. Yeah, report web vitals. So if you just add a small function of report web vitals in your app.js, then basically Next.js relays your core web vitals store to this function, and then you can just basically integrate this function to your whatever your backend is, wherever you want to ingest this data. So that's another cool way of dealing with in one of the frameworks. I'm very sure that there are good integrations in other frameworks as well.
I think we have one question in chat. Let's take that. So Sriram has this question. CLS is restricted only to first viewport that is visible on screen. What about page shift on scroll again due to lazy loading stuff?
Right. So this is like a very tricky part. Like when you go to web page test and other stuff, what you will see is CLS being reported up till your page load was completed. When your page load was completed, these lab testing tools will basically stop recording what's happening on the page, right? So you'll get your CLS score up till then. However, in practice, the data is being collected through the entire user session. So if if a user scrolls and then like something loads at the bottom, and then they scroll at the bottom, even that content shift, even that is recorded under CLS. So CLS is recorded for the entire user session. That's why your data from either the Web Vitals library or such integrations from frameworks that we talked about, they will report the right value of CLS. The web page test will only be a good idea of what happened up till loading time or up till when the test was stopped. In practice, CLS is recorded for the entire user session. Yeah.
Great. So I think we are done with the questions. So next question is about the resources. What are the resources you will suggest to actually learn more about this core web vitals?
Right. So one of the resources is basically the link that I just sent. That's a great place to start reading about it and understanding what these three in detail are. They are continuously being improved. So there might be where you find something that something is updated versus what I said, but that I tried to be as fresh as possible in my knowledge. Uh, so apologies if you find any differences. And they do, and they are definitely bound to evolve in near future so that they become more and more closer to how user sees your web applications. That is one thing. Second thing is the Web Vitals library by Google Chrome. So that's a good place to start to see how you can get the data from real user metrics. That is another thing. And then third thing, if you're just already using Next.js, there's a lot of built-in integration On Vercel.com, you'll the documentation of Next.js, you'll find some good resources.
Great.
Yeah.
Okay, so cool. So I don't think so. We have any more questions. So the next question is again for you. So is there anything you want to promote on the
No,
channel?
I
So
guess I have already shamelessly plugged everything that I have worked on or I have knowledge about, what people have worked on or are working. So yeah, that's pretty much the list of resources that I have. Yeah.
yeah, so we are done for the day. We don't have any questions in
Mhm.
chat. But Pratik, in case anyone has some queries, what will be the best
Yeah.
place to actually reach out to you?
The best place to reach out to me would be the background that you have. That is Twitter. I
Twitter handle.
feel I feel my Twitter handle is visible in a good manner. So
I think
please,
yeah, should be.
yeah, please feel free to reach out to me. If I don't have definitive answers, I'll probably either relay your question to the Chrome team working on this, or will either send this directly to them.
Thanks a lot, Pratik. So this is it for the day, and thanks a lot, Pratik, for giving your time and answering
Sure,
all the questions. So it was really great to know more about Web Vitals, and
sure.
yeah. So okay, so that's it for the day, everyone. And on closing notes, we have our next episode coming up, of course, next Friday, and let me see what we are going to talk about because we. This is April, right? So, okay, May. Yep. So, in May, we are going to talk about the first episode will be with Debbie O'Brien. She is one of the GitHub star as well as GD for web, and she will be talking about Bit. I'm sure you might have, in case you have been working on React, I think Bit is one of the cool library or whatever. I think it is a framework where you can actually build on web. You can just publish your React component or Angular component, and then you can just use it directly from the uh, whatever URL they give. So I really like the product. So Debbie will be uh, talking more about Bit. She is a developer advocate at Bit. So that's the next episode which we'll have. And apart from that, of course, be safe. I mean, times are tough, and try to help others. These are the times where everyone needs your help. So if you can just help a single person, that will be great. And that's it. So stay at home. Apart from that, we Saturday, Sunday. So I have this live stream coming up. We will be talking about Angular. So we are already done with TypeScript, and now Angular part will start. So in case anyone in your uh, in a network wants to actually learn about Angular, just let them know about this live stream, which is free. And these I'm actually streaming the entire Angular getting started course, which will include everything which the knowledge you can take, and then you can start working on enterprise application as well. So that's tomorrow 6 p.m. to 8 p.m. IST. So see you there as well. So that's it. Thanks everyone. Thanks Prateek for joining. Bye everyone.
Thank you. Yeah, stay safe.